Good morning, everyone. Welcome back to Math 115. So today we're going to talk about section 4.3, and we're going to have a quiz today. Yay. Okay, so homework 4.1 is going to be due tomorrow, and 4.2 is going to be due on Monday. So those are the homework assignments that you have coming up. I'll post 4.3 soon. Another thing I want to remind you of is I'm not going to have office hours today, okay? No office hours today. I moved them to yesterday. So if you want to study with a tutor, go to the tutoring center. That would be the best move. All right. Any administrative questions before we start in on content for today? Yes.
For the homeworks, do the times that they're due change?
Yeah. It's because I copy these homework assignments from another instructor. I'll try to put the homeworks back to midnight. I don't know why they've been set to 10 p.m. or something like that. I'm gonna put them back to midnight so that you can work until then. I just keep forgetting to do that. Any other administrative questions? Okay, doesn't sound like there are, so let's move backwards, actually, to discuss what we talked about last time. So we reviewed the unit circle, these special right triangles, and the Pythagorean theorem in order to prepare us for trigonometric functions. Okay, so trigonometric functions, they have an input t, and you can think of the input in two different ways. You can say, well, I'm going to put the angle t inside the unit circle. Okay, that's one way to view the input, is as the angle inscribed inside the unit circle. The second method to think of the input is to think, well, I'm going to take the axis of all the inputs, and I'm going to line it up here and curve it around the unit circle. Curve it around the unit circle. Then the input will correspond to the corresponding arc length on this unit circle. And so what do we ask? We ask, if I walk 1 foot along the unit circle and I end up at a point, we ask ourselves, what are the coordinates of that point? And the x-coordinate corresponds with the cosine of that input, and the y-coordinate corresponds with the sine of that input. Okay, so two different ways. You can say, well, I'm going to put an angle in, and I'm going to point at a point on the unit circle. Or the other way is to say, I'm going to walk t feet around the unit circle. Okay, because when we use radians to measure this angle, the angle measurement will be the same as the arc length, right? Will be the same as the arc length. Okay, so we learned basically the steps which we use to find sine, cosine, tangent, cosecant, secant, and cotangent of various angles. So what do we do? The steps go like the following. The first step is to put the angle in the unit circle in standard position. What was step 2? Once we had the angle in here, step 2 was to complete the triangle by dropping a vertical line. So, complete triangle with vertical line segment. And then, once we had a triangle, who can tell me what is going to be step 3 for figuring out what these two coordinates are? We take the angle, we put it inside the unit circle, we make the triangle. Why do we make the triangle? So that you can find the other sides using the theory of what? Special right triangles. Okay, special right triangles. So 3 is use special right triangles to solve for the lengths of the short legs Why is it that I only need to solve for the length of the short legs? Don't I also need to solve for the length of the hypotenuse? No, why don't I need to? That's okay, thank you. That's right. It's 1. We don't need to solve for the length of the hypotenuse because it's always 1. Because it goes from the center of the circle to the outside of the circle. Okay? A line segment which goes from the center of the circle to the outside of the circle, we call it a radius. And the radius of the unit circle, we call it the unit circle because the radius is 1 unit. Okay? So, this is the steps to finding out what are the coordinates, right? This tells us the coordinates of the point. So the last step after that is to say, well, which coordinate do I need? If it's sine, I need the y coordinate. If it's cosine, I need the x coordinate. If it's tangent, I need the ratio between y and x. And then we have the reciprocal functions. So these ones are all just 1 over sine, 1 over cosine, 1 over tangent. Okay, so are there any questions about this brief review? Okay, so what I want to do is just to impress upon you the importance of these basic concepts. So it's, there are some things in this class where you can probably get by understanding it like 70% of the way, and then we move on, and it's good enough for you to do well on the exam. But the third exam is going to be lots and lots of trig. The final will have trig on it. And it gets harder from here. So if you need to have a basically like a 100% understanding of this in order to kind of move forward with the material, because it's going to all build on this basic system. So I'm saying that not to try to scare you, but just to try to impress upon you the importance. And because I think it's so important, I think we should do another full example. Maybe 2 full examples. So what am I going to do here? Let's see how we would compute sine of 120 degrees. How would I compute sine of 120 degrees? Well, let's follow the steps. Well, actually, the first step, which I should put as step 0, is obviously draw a unit circle. If your problem doesn't start with you drawing a unit circle, then I don't know what. You're going to get no presents from me for Christmas. You're going to get math problems for Christmas. We don't want that. Okay, so what do we do first? We draw a unit circle. So first things first, we draw a unit circle. So here's the unit circle. It's really easy to draw on this thing because it just fixes everything for me. Okay, so now I need to put in the angle, right? That's step 2, is put the angle in the unit circle in standard position. So the first leg of the angle, the initial side, always goes to the right. How about the terminal side? Which quadrant is it going to end in? 1, 2, 3, or 4? If it's 120 degrees, which quadrant do we think? 2, right? Because 90 degrees would be right here. 180 degrees would go straight across, and 120 is somewhere in between. So what I want to do is think about this in terms of its component parts. I can think of 120 as being 90 degrees plus 30 degrees, okay? And I have an idea of what a 30-degree angle looks like. It's like less than half of a 90-degree angle, right? It's 1/3 of a 90-degree angle. So I'm going to go all the way to here, and then I'm going to go 1/3 of the way from here to here, okay? So not all the way. This would be half, and here's like 1/3, okay? So 120 degrees would look something like this, okay? Something like this. Okay, so now what is my goal? My goal is to complete the triangle with a vertical line segment, okay? So I'm going to put the point here. This is the point I'm interested in, and I'm going to complete the triangle using a vertical line segment, okay? So I start at the point, and I go to the x-axis. You always start at the point you are on and go to the x-axis. So let's see that. It looks like this. And then what are going to be the interior angles of this triangle? Well, we know what this angle is. What is this angle? 30 degrees. So The rest of this has to be what? 60 degrees. So this is a 60-degree angle, which means if this is a 60 and this is a 90, then what does this one have to be? A 30. Okay, so now what do I do? I'm not going to go back up. What do I do now? How do I figure out? What is my goal? Is to figure out what are these coordinates. So I know if I have a 30, 60, 90 triangle, right? Why is it useful? Because if I know the side, one of the side lengths, I can determine the other two side lengths. So what should I do now? Yeah?
We know the hypotenuse is 1.
Yeah, the hypotenuse is 1, okay? Never ever forget. So a lot of students get to this step and they're like, well, oh, I don't know what to do now because I have the triangle, but how am I supposed to... I don't see the connection between the triangle and the point. Well, you need this extra piece of information. The hypotenuse always has length 1. So if the side across from the 90-degree angle is 1, what then will be the length of the side across from the 30-degree angle?
2.
Should we double it? Well, let's look visually. If we look visually, I think this one looks somewhat longer than this, right? So there is going to be a doubling kind of a relationship, but it's actually in the other direction, okay? So in this case, we know that we could get the 90-degree angle side by taking the side across from the 30-degree angle and multiplying by 2. That's what we learned so far. But of course, if we want to go in the other direction, what should we do? Not multiply by 2, but divide by 2. Okay? So that's how we do the special right triangles. So in this case, this length here is going to be 1/2. And how about this length? How do I do that one? Yeah, so, sorry, what did you say? Yeah, exactly. Where x here is going to be the length across from the 30. Okay, so we need to remember basically how to go from each side to each side. If you think about it in terms of going from the 90 to the, if you think about it from going from the 90 side to the 60 side, what you need to do is multiply times the square root of 3 and divide by 2. Or if you want to say I'm going to go from the 30 side over to the 60 side, then you just have to say I'm going to multiply by the square root of 3, right? So you need to memorize basically how to go from one side to the other side and from the other side to the 1 in order to complete these quickly. So here we just put square root 3 over 2 because that's what we get when we take this side and multiply times the square root of 3. Okay, so what are the coordinates then? What's the x-coordinate of this point? Negative 1/2, right? Because this length is 1/2, but it's 1/2 to the left. So the point will have x-coordinate negative 1/2. And how about the y-coordinate? It's going to be root 3 over 2. Okay? So I'm not quite done yet, am I? Because my goal is to figure out what is sine of 120. So what is it going to be? Yeah, square root 3 over 2, because sine of 120, right? This should be the y-coordinate of this point. If I look at the y-coordinate of this point, it is square root 3 over 2. Okay? What about tangent of 120? What would I get if I did that? Yeah, I'm going to take root 3 over 2, and I'm going to divide it by negative 1/2. Take the y-coordinate, divide it by the x-coordinate. So if I did that, I would get root 3 over 2 times negative 2 over 1, which would be negative square root of 3. Okay? So the steps go: draw a unit circle, put the angle in the unit circle, complete the triangle, and then solve the triangle using special right triangles. From there, it's just, we get the x and y, and so to find any of these, you just plug in the y or the x or the y and the x. All right, let's do one more example. One more example before I move on to that. Let's do, I'm going to combine these two. Let's do secant of negative pi over 4. What kind of angle is negative pi over 4, besides being negative? What would it be in degrees?
45.
It's 45, right? So it's, you can remember because pi over 2 is a 90-degree angle, so pi over 4 is half of a 90-degree angle. Okay, so let's draw our unit circle. Pretty good. Okay, so we put in, wait a second, negative pi over 4. What's that going to be about? Well, I'm always putting the initial side here. But what's the difference between a positive angle and a negative angle again? Yeah, negative angle. Okay, positive angles are measured counterclockwise. Negative angles will be measured in the opposite direction, clockwise. So I need to go 45 degrees clockwise, which would put me right here. So here's the point. And now what do I need to do? I make the triangle. How do I make the triangle? Like this. This gives me a triangle here. No, we should always complete the triangle by drawing what? Everyone together, a vertical line. Okay, good. So we draw a vertical line. That's how we complete the triangle. And what are the angles inside of the triangle? What's this one? 90, right? Because it's perpendicular. Vertical line is perpendicular to a horizontal line. And how about this angle here? Yeah, 40, whoop. It's going to be 45. So I just want to say, you could be confused when you say, well, shouldn't it be negative 45, right? Shouldn't it be negative 45? But when we think about the triangle, okay, we think about all the angles inside of the triangle, we forget about the fact that we were initially, we are initially in the coordinate plane. Now we just have a triangle to solve, okay? And the interior angles of a triangle are always measured in terms of their positiveness, so that we can say, well, we need to make sure they all add up to 180. So even though it's negative 45 degrees, you could say that this is a 45-degree angle if you were to measure it from here to here, right? That would be a 45-degree angle. Okay. So, shoot, now I'm stuck. Why am I not stuck? I know the hypotenuse. Okay, so we know the hypotenuse is 1. So how do I get the short legs if I know the hypotenuse is 1 and I have a 45, 45, 90 triangle? Multiply by the square root of 2? Probably divide by the square root of 2. Yeah, it's tricky because we're always starting on the long side, and so we're used to doing these special right triangles where we go from the short side to the long side, but every time we're going to be going from the long side to the short side, so it's like kind of backwards. And I agree, it's kind of confusing. It's especially confusing when you consider that the long side is 1, so you're like dividing 1 by the square root of 2, it just feels kind of wrong. But that's what we need to do so that this side should be 1 over the square root of 2, so that if I were to go from this side to this side, what would I do? I would multiply this with the square root of 2. And if you multiply 1 over square root of 2 by the square root of 2, then we would get 1. Okay? All right, so that's 1 over square root of 2, which of course we can rewrite by rationalizing. Multiply by square root of 2 over the square root of 2, and we get square root of 2 over 2 and square root of 2 over 2. Or did I make a small mistake? Yeah, the y value needs to be negative. Where is this point? It's in the fourth quadrant. Points in the fourth quadrant have a positive x value and a negative y value. So I should make this one negative, because what are we describing here with this triangle? When we solve this triangle, we're not describing the coordinates of this point. We are describing the lengths of the sides. One sec. We're describing the lengths of the sides. So this length is square root 2 over 2. But when we think about this point in the context of the greater coordinate plane, we know that we need to travel that length in the downward direction, which is why we make this one negative. What's your question?
Since it's a 45, 45, 90 triangle, do you just assume the two sides are the same?
Yes, exactly. So that's what I've done here. So in a 45, 45, 90 triangle, you may recall from geometry that if you have a triangle, if there are two angles inside whose measurement is the same, okay, so if these two angles are congruent, meaning same measurement, then the side lengths across from those two angles will also be congruent, meaning same length. So I only needed to solve for this side of the triangle because I know that the other side, this side's going to be the same as that one. Does that answer your question? Okay, any other questions on this one? Wait, are we even done yet? No, we're not done yet. We're supposed to find secant. Now secant, I think secant sine, right? No. The world is not as it should be. Secant is going to be equal to what? 1 over cosine of negative pi over 4. And what is cosine of negative pi over 4? Is it going to be the x-coordinate or the y-coordinate? It should be the x-coordinate. So cosine of negative pi over 4 is the x-coordinate. So we're going to take 1 and divide by square root of 2 over 2. So 1 divided by square root 2 over 2 is the same as 1 multiplied with 2 over the square root of 2, which is 2 over the square root of 2. And am I done? Or one thing left to do. What is the last thing? Rationalize the denominator by doing what? Multiply the top and the bottom by the square root of 2. Very good. So I get 2 square root of 2 over 2, and I can cancel the 2's, and I have square root of 2 as my final answer. Okay, any questions on that one? Okay, I'm going to move on now. So this is something which you can look at. Yeah, don't get overwhelmed. Because, look, I don't want you to become overwhelmed by this. I just want to show you this. This is the sort of thing that you can keep, like, I don't know, on a piece of paper by your desk or something like that when you're doing your math homework. It'll help you as a key. What I don't recommend anyone to do, although it's okay if you do this, I don't recommend anyone to try to memorize all of this. I know Chris has it on lock. Chris has it on lock. He has memorized this entire thing, which kudos to you. But most people don't have Chris's superhuman memorization powers. So, what I recommend you to do is draw the triangle, okay, and then you can solve it using special right triangles. So you can see in here all of the various triangles that you could have. One triangle would look like this, okay, for pi over 6, right? Or you could have one down here, which would be like 4 pi over 3, would look like this, right? And so on and so forth. And you can see basically what are the angles that we can do. We can do 30-degree angles, we can do 45-degree angles, and we can do 60-degree angles, and we can do, of course, 90-degree angles as well, right? So we're basically just going to, you can imagine me, if I were to drag this point this way, like if I were to have these two legs of this thing were like pieces of string, right? Then I could drag around the unit circle. I could drag this point where I'm holding on to the two pieces of string this way, and then the pieces of string would look not like that, but like this, right? You see what I mean? It's like pieces of string here, and if I were to drag it even further, then those two pieces of string would get really close together, like here, right? Would be this triangle, and then if we were to go all the way to 90, those two pieces of string would just overlap, and we wouldn't have a triangle at all. But that's okay, because I know how to find this length already. It's the radius. Okay, so what would, for example, sine of 90 degrees be? It would be the y value of the point which is pointed at when I put in a 90-degree angle here, which would be this point up here, right? It would point straight up here, and the y value of that point is 1, so I get 1. Okay. What about cosecant of 0 degrees? Well, cosecant is what? 1 over sine of 0. And what is sine of 0? That would be, well, I'm going to put it at an angle like that just goes straight over here. And then what do I need to get? The x value or the y value? The y value for sine. So what would I get? 1 divided by 0. Uh-oh. So there's some times where I can't actually do this, right? There's some times where I can't actually do this. So we would say cosecant of 0 is undefined. Okay? So if you want to memorize this, fine, but I don't recommend it. I would say just know how to put an angle in here and then know how to draw the triangle, and then you'll be able to figure out what these coordinates are. But it's not too hard to look at them and see that all of the values are basically going to be like one of 4 numbers, right? It's either 1/2, square root of 3 over 2, square root of 2 over 2, 1, or 0, right? So 5 numbers to remember, and they're either going to be positive or negative based on which quadrant you're in, right? If we're in the first quadrant, then look, all of them are going to be positive. What about if we're in the second quadrant? If we're in the second quadrant, all the y values will be positive, and the x values will be negative. If we're in the third quadrant, everything's going to be negative, right? So on and so forth. All right. So any questions on basic trigonometric functions before we move on to some more complicated things? By the way, I say basic, I don't mean like that it's easy. That's not what I'm trying to say. What I'm trying to say is just that comparatively to what we'll do later on, this is sort of the basic setup. So it takes a while to get used to this. So I don't want anyone to feel like, oh, like I don't understand this yet and feel like really bad. Okay, it just takes time to get used to this stuff. Okay? All right, so let's move on to next chapter then, and let's talk about what we already just talked about, which is the signs of the trigonometric functions, right? The signs of the trigonometric functions. So this acronym here is going to just tell us the signs. This just tells us the signs of sine, cosine, and tangent. Why is that enough to know the signs of all 6 trigonometric functions? Exactly, because cosecant is just 1 over sine, right? So whatever the sign of sine is going to be the sign of cosecant, right? As well, because we just take 1, if we divide 1 by a negative number, it's a negative number. So they have the same sign. So this will tell us the signs of the trigonometric functions. And remember, we're just talking about what is the sign of x and y, right? We have x, y. If we have a point here, then x is going to be positive. Y is going to be positive. So what is going to be the sign of sine? It will be positive. How about cosine? Again, positive. And if I take a positive number, divide it by a positive number, what am I going to get? Again, a positive number. So what is this A going to stand for? It says all trig functions positive. Okay, now let's look at a point in this quadrant. Its x value will be what? Negative or positive? It's going to be negative, and its y value will be positive. So sine is the y value. It's going to be positive. Cosine is the x value. It's going to be negative. How about tangent? Why is tangent going to be negative? Yeah, because one of them is negative. If I take a positive number, aka the y value, or the sine, and I divide it by a negative number, aka the x value, then I'm going to get a negative number. So what does the S stand for? Sine is the only positive one. Okay, and T, what is it going to stand for? Probably tangent, right? Because what is this point going to be? It's going to be negative, negative. So the sine is negative. The cosine is negative. But if I take a negative number and I divide it by a negative number, I'll get back a positive number. So tangent is positive. And the last one is, of course, for cosine is positive because what are we going to have? We're going to have positive, negative for our coordinates. So the mnemonic device for remembering this is, okay, so remember the quadrants go 1, 2, 3, and then 4, right? 1, 2, 3, and then 4. So the way we read this is A, S, T, and then C. So A, S, T, C tells you which ones will be positive. The way to remember it is all students take calculus. That's right. I don't appreciate that voice you did for me, though. All right, all students take calculus. So that's the mnemonic device to remember where the trig functions are going to be positive or not positive.
I spent my entire, not last year, literally doing this. I'm so bad at it.
Then you're going to be well equipped to do it in our class, right? Okay. I need to set an alarm to remember to do the quiz.
Harder quiz?
9:45, so we
We should do partner.
go back 15 minutes from that would be 9:30, so let's do 9:28.
To give people the initiative to come to class. Partner quiz?
What if somebody's sick, though?
That's their problem.
It's not an excuse. Come to class.
No, please don't come to class if you're sick. All right, so are there any questions on the signs of the trigonometric functions, when they're going to be positive or negative.
What was the question?
I was just asking if there are any questions. Okay. Then let's move on and talk about something called reference angle. And we already kind of did this. When we did the 120 degree sine, right? Remember what we did? We had to check, well, if this is 120 degrees, we had to figure out what were the angles inside of this triangle. And how did we do that? We did that by taking, well, I know that from here to here would be 180, and I just subtract 120 from that in order to get that this angle here should be 60, right? Because that's the relevant angle for figuring out what are the proportions of this triangle going to be, right? We need to know what is this angle, because if we know this angle and this one's a right angle, we'll also know this angle, and so on and so forth. So reference angle is the name we give to this angle here. We call it the reference angle. So how do we figure out what the reference angle is? It's pretty simple. You just find the angle which is formed by what? The terminal side of our angle and the x-axis. Okay? Actually, there's two angles formed by the terminal side of this. There's two angles formed by the terminal side and the x-axis. We want the smallest one. Smallest angle formed by the terminal side and the x-axis. So for example, if we did 250 degrees here, what would be the reference angle? Well, we want to form the angle between our terminal side and the x-axis. So the x-axis is this one. So which is the angle? Are we going to have angle 1 or angle 2 be our reference angle? I heard someone say 1, but why 1 and not 2? Yeah, it's the smaller one. 1 is the smaller one, so that's going to be our reference angle. So in this case, our reference angle would be this angle here will be our reference angle. And how do I figure out what its measurement is? If theta is 250 degrees, so this is 250 degrees, how do I know what the angle here in green is? 180 minus 250? That would give me negative. Yeah, we want to do the other way around. 250 minus 180. I don't know what you're saying there, Lauren. Oh, okay. Good. Okay, so what do? We take, in this case, 250 and we subtract 180 from it. So you might think, well, is it always just I subtract 180? No, not always, because in this first one, I kind of primed you in a bad way. I said, well, this one, in this case, it was 180 minus 120, and that gave us 60, right? But why did this give us 60 this time? It's because this reference angle this time was up here in the second quadrant, right? And our angle later on was in the third quadrant. So it's a question of which angle is the biggest angle. We just take the biggest angle minus the smallest one, or minus the smaller one, in order to get the reference angle. So in this case, we go all the way to here and we take away the 180 degrees that it took to go from here to here, and then we're left with whatever is left in order to get the rest of the way here, which is, what, 70 degrees? Okay. So that's how we do reference angle. Any questions on reference angle? All right, then let's keep on going. So next up, I want to talk about how are we going to deal with angles that are bigger than 360 degrees. For example, how would I do something like secant of 59 pi over 6? Well, 59 pi over 6 is like almost 60 pi. It's 54 pi, which would be 54 pi over 6 would be 9 pi. So this is like 9 pi plus 5 pi over 6, right? Something like this is what this is. So what the angle looks like is something crazy. What are we? 9 pi. That means we go all the way around 4 times and then another halfway around. So this is like 1, 2, 3, 4, and then the extra pi gets us another halfway around, and then we still have to go 5 pi over 6, so it goes all the way to here. So this is the angle 59 pi over 6. So needless to say, this is kind of annoying to deal with, but we can recognize something. This angle will point at the same point on the unit circle as will the angle, just this negative pi over 6, right? Just negative pi over 6 would point at the same point on the unit circle, right? So what is that to say? That is to say that the value of sine for any angle will be the same as the value of sine for that angle plus 360 degrees, right? Plus 360 degrees. So, for example, let me show you. We already did sine of 120, right? What was sine of 120 when we did that? We got square root 3 over 2. So sine of 120 degrees was square root 3 over 2. So too is sine of 120 plus 360. That would be 480, right? So let me show you why. If we have a unit circle, then here is the angle 120. And what does the angle 480 look like? It looks like this. 480. And 480 points, again, at the exact same point on the unit circle as does the angle 120. So the coordinates of this point will be, I think, like they were negative 1/2 and then square root 3 over 2, right? So sine, in both cases, is going to be the y value of the point on the unit circle which that angle points at. Since these two angles point in the same direction, i.e. they are, what was the word we had for angles which point in the same direction? Coterminal. They are coterminal angles, so they point at the same point on the unit circle, and so therefore sine of 120 degrees is the same as sine of 480 degrees, is the same as sine of what we would get if we added another 360, right? Or if we added another 720 or another 1080, right? Okay, so that's coterminal angles. So what do we do when we are tasked with finding secant of 59 pi over 6? What we do is incrementally subtract by 360 degrees, or equivalently 2 pi, until what? Until this angle is between 0 and 2 pi, or respectively, oh, that's really bad, or respectively 0 and 360 degrees. Okay? So that's what we're going to do. So we have 59 pi over 6. 59 pi over 6, what am I going to do? I'm going to subtract 2 pi, which would be 12 pi over 6. Well, what would I get if I did that? I would get 47 pi over 6. Is this between 0 and 2 pi? Is 47 pi over 6 between 0 and 2 pi? No, it's bigger than that, because what is 47 divided by 6? It's something bigger than 2. Okay, so we're going to go again. So let's do 47 pi over 6 minus 12 pi over 6 equals, let's see, this is going to be 35. Okay, and then we're going to go again, over and over again, until we get something which should be less than 12, right? So subtract 12 again, we get 23. Subtract 12 again, we get 11 pi over 6. And here's where I'm going to stop. I'm going to stop at 11 pi over 6 because 11 pi over 6 is less than 12 pi over 6, which is 2 pi. And it's bigger than 0. Okay, so we just subtract incrementally until we get here, right? Okay, so we know that, what am I trying to do? Secant? Okay, so secant of 59 pi over 6 is equal to secant of 47 pi over 6, 35 pi over 6, 23 pi over 6, and 11 pi over 6, which is the one that we're going to use, 11 pi over 6. So now what are we going to do? We're going to draw our unit circle and we're going to do it. So secant of 11 pi over 6. So what does 11 pi over 6 look like? Which quadrant? Fourth, right? We go almost all the way around. And what is our reference angle in this case? It's going to be this angle here. And what is the measurement of that reference angle? Just this angle. Just this angle is going to be 30, right? 360 minus 30. So this is a 30, and this is a 60, and this is a 90. And what else do we know about this triangle? Hypotenuse is 1. So what is this side length going to be? How do I get the short leg if I know the longest leg? Divide by 2, so it should be 1/2. And then this side length should be, well, if we're just talking about the side length, it's going to be 1/2 because the length is always positive. But you're correct in that the coordinate, the y coordinate should be negative 1/2, right? And how about the x coordinate? Multiply which one by square root of 3? The short leg. We multiply the short leg by square root of 3 in order to get root 3 over 2. Okay, so these are the coordinates of this point. So which one is going to be relevant for secant? Yeah, cosine. So this is going to be 1 over cosine of 11 pi over 6, which is going to be equal to what? 1 divided by the square root of 3 over 2, which is 2 over the square root of 3, which is 2 root 3 over 3, if we rationalize. Okay, so we can handle something which is bigger than 360 or bigger than 2 pi. So I hear you all packing up. Give me 1 second. I got to do one more example, and then we'll do the quiz. So what I've said here is a little bit misleading because I said, well, just subtract by 2 pi until you can't anymore, right? But what if we have something like the following? What would I do if I wanted to do cosine of 3042 pi? Well, am I going to subtract by 2 pi, and then by 2 pi, and then by 2 pi, like 1,500 times? No. I'm going to see, well, this is a multiple of 2, right? And how does this go? This angle measurements go pi, and then 2 pi, and then this would also be 3 pi, right? And then this would be 4 pi, and then this one would be 5 pi, and then this one would be 6 pi, right? So 6 pi means we would go all the way around. That's 2 pi, 3 pi, sorry. This is 2 pi, this would be 4 pi, this would be 6 pi, and so on and so forth. So what am I gonna get what is my reference angle gonna be for 3042 pi? Yeah, it's gonna be 2 pi or actually 0. So we want this angle going this direction. This is our terminal side. So what is cosine gonna be? If we were to draw in a unit circle, then cosine is gonna be the x-coordinate of this point, which is what? It's 1, 0, so cosine of 3042 pi is 1. Okay, so what does this really mean? This means you go around 1,521 times around the unit circle, and then you end up pointing right back where you started. Okay, oh, thank you. This is that's the first time I've gotten applause in our class, I think. All right, so please clear your desks.
Well, for you, obviously not.
I don't think it's too bad.
You are an
I don't think it's too bad even for all of you. That came out wrong. So please put all of your devices away, phones and any Apple Watches or other devices that you might have. Please put them away in your book bag. And please put all of your notes away and zip it up so that you can't see into your bag, please.
Do we get to drop an exam, or is it just 2 quizzes? Like at the end?
I will drop.
2 quizzes for an exam.
No, I'll drop 2 quizzes. I'll drop 2 homeworks, and if it helps you, I will replace your lowest exam score with your final exam score.
Oh, so wait.
So let's say that you did the exam, you got a 40 on the first exam, and then 70, and then 70, and then on the final you get an 80. I will replace your first score where you had a bad exam with your final exam grade, so your final exam grade will count both for your final exam and for your lowest exam score. So that should give you some insurance if you have like one exam where you just really messed up.
What if you just really mess up on your final?
I don't know what to tell you.
Being USC now. USC
I called it USC.
No, mine.
So please leave the space down
We could start right now. Yeah, I mean, that's right.
I go here obviously, so no, I'm going to the one in California.
Sorry. We couldn't change our hey, pass the quiz. Well, you was sitting like this, and I was like,
Oh, you don't need to do that.
It'll be okay. It'll be okay.
City of Praise.
Does everyone have one? Yeah? Okay, you may begin. Hey, please quiet down.